So for homework, you guys were actually asked to write an equation that would model this function that's there. So we're really being asked to write an equation for this graph, right? For this function. Now, I'm gonna go ahead and I already know what the function is because I figured it out real quickly. But I want to walk through how I figured it out. Okay, and so that's what I'm going to do here. And then at the end, we'll kind of see what I had typed in on Desmos, just so you can see I'm not pulling the wool over your eyes. All right, so when I look at this, I would agree with you. This looks really confusing. Now, it looks like an exponential function, but most exponential functions I'm used to, they either do something like this, or they do something like this, right? They're either exponential growth or decay. And so what I can tell is that this function has been manipulated. Now, what I know about exponential functions is I know that they actually always have the x-axis as their asymptote unless they've been modified, which indeed this one has been modified because if you look at where the horizontal asymptote is, okay, our horizontal asymptote is there, which if I wanted to go ahead and, it looks to me then like if I want to go ahead and shift it back, it looks like it was shifted up 5. Which means if I went ahead and shifted it back to where it was before, what I would actually get is I would get something that, right, my tracing skills are leaving lots to be desired. But I would have something like this, right? Which at this point in time, I actually could model this one if I really chose to. Let's go ahead and do it in two ways. If I went ahead and kept thinking about it as being modifications, which I'll do, I'm used to the functions being up in the positive y values. This one is down in negative y values, so it looks like it actually got reflected, can't spell apparently, over the x-axis. So if I went ahead and reflected it back, well, what would it look like? Well, it would look something like, right, something like this. Okay. And then we kind of do one of these, And actually, I'm wanting to get some more specifics too. So like specific points, notice how I'm working off of that one. Because when that shifted down 5, it actually became -2. And that's how I know where it is now. Now, if I got another specific point, let's say, look where that one is. If that one shifted down 5, right, it would be at -6. And so now, right, when it got, because shifted down 5, it's at a height of -1. So if it shifted down 5, be at -6 on the orange one. But then when it got reflected, wouldn't it show up as +6 on this green one? And so I can see that. And what that does is that allows me to figure out some other stuff. So what I can tell from this now is that 1, it's exponential decay, all right? 2, I can see kind of that initial amount, right? I could actually make a table, if you will. I could go ahead and put 0, 2 on my table. Actually, I would make it look like a table. This is for the green one, so maybe I shouldn't be doing it in black, huh? So 0, 2 in my table. And then I also have another point, which is a -1, 6. And keep in mind, I know it's exponential, which means I know I have a common ratio, right? A common multiplier. And so if I go ahead and figure out that ratio here, I'd actually multiply by 1/3, right? And if I understand the structure of an exponential function, like this, y equals a times b to the x, well, I know that the base is that repeated multiplier, which would be, in this case, 1/3, right? And I know that the a value is really kind of, it's a stretcher as well, but in this case, it's also the initial amount, right? So in this case, it's actually 2. So this is the green one. Now, this is the green one. Let's go back. Well, we want to reflect it over the x-axis to get to the orange. Simple enough. Making any function negative, right? Multiplying it by negative, we'll flip it over the x-axis. And then I want to shift it up. I'm going to shift it up 5, right? To get it back to the original. So let's go ahead and do that. Get to our original. And just shift it up. And so this is the function that we actually should have. And this is one way I can kind of think about it. Okay? And if I go ahead and show you the function that I had graphed there it is. You know, the negative 2 times 1/3 of the x plus 5. Okay? Now, there is another way to get this function. And I guess if I go back, it's not incredibly different. I would just take maybe one less step. I still would want to see that this is actually shifted, right? So I'd still want to see that this is actually the graph if I had shifted it. Because I don't really like the fact that asymptote's there. It makes it easier for me to see at the x-axis. But then what I could do is I could just think about where that point went and where that point went. And I know that they would go here, you know, and then down to the other. So I could actually just find some points on there. And I know I'd have 0, -2, and I'd also have, let's go back up from there, -1, and then that other one we said would be -6. So again, what I can tell here is there's the 1/3, right? Because I'm really taking 1/3 of there. There's that common ratio. And I can see my starting value as being -2. So in this case, I could have said -2 multiplied by 1/3 to the x. Right? I could have done it this way. And then I could have just said, okay, and then I want to shift it up 5, right? Because I want to get that orange one to become the red one. So that's another way I could have viewed this one.